now that we have talked about the atmosphere, the next thing that we want to talk about is the hydrosphere, which is the watery part of the earth. And we want to talk in particular about the hydrological cycle. So where does the water come from and where does the water go to? So we can start anywhere that you want with this hydrological cycle, but I like to start with volcanoes. So volcanoes are going to produce water. That water is going to go into the atmosphere. Once it's in the atmosphere, it can condense into rain. Okay, now it can rain either down on the oceans or it can rain down on the land. So let's say that it rains down on the land. Where could it go? Well, it could be frozen. So that water could end up in glaciers, the cryosphere. The water could run on the surface of the land in terms of like rivers. The water could sink into the land and become groundwater. The water could get into plants and animals, and then those plants could transpire. They could give off the water back into the atmosphere. The animals could breathe out water. That could go respire. That could go into the air. The water could evaporate from the surface of the land and go into the air. Okay, then let's talk about what could happen in the oceans. So in the oceans could evaporate and the water could go back into the air. Another thing that could happen is the water could get into the plates, could saturate the lithosphere, and then as the lithosphere goes back underneath the continent, subduction, that water could come out and then go back out through the volcanoes. So just know the different routes that water can take for the exam. All right, so how does the geosphere affect the climate? So I do want you to understand what a rain shadow is. So if you've got moist air that is coming across a continent and then it comes to a mountain, so as the moist air climbs, it gets colder. And it might get so cold that it condenses into a cloud and it starts to rain on this side of the mountain, so that by the time the air makes it over the mountain, it might have gotten rid of all of its water, so that when it's on the other side, it's completely dry. So we're going to call that a rain shadow. Okay, you should know how volcanic gases affect temperature. Volcanic gases can make the climate hotter, and volcanic gases can make things cooler. So the stuff that comes out of the volcano. So the stuff that comes out of the volcano, the CO2 and the H2O, are greenhouse gases. That's going to make it warmer. On the other hand, some of the other stuff that comes out of a volcano is going to be dust and ash. And that can block sunlight, so that makes it cooler. So these two things can make the climate warmer. This can make the climate cooler. Now, which one in the short run, the dust is going to win. And so after a volcanic eruption, things are going to get cooler because of the dust. But eventually the dust settles. These gases remain in the atmosphere. So over the long run, the climate gets warmer as a result of volcanic action. Okay, then we've talked about how the position of the land masses can affect global ocean currents, and that can trigger an ice age. And so this is just a picture showing the position of the plates before the collision of North and South America, and then the ocean currents afterwards. Okay, then another thing is carbon dioxide mixes with water to make carbonic acid. And carbonic acid can dissolve limestone. So it can cause chemical weathering of rocks. Okay, then another thing is changing sea level, is that at a mid-ocean ridge, it can elevate the topography of the ocean floor, and then that can displace water, and that water can slosh onto the continents, so sometimes the continents are submerged by the ocean. Next thing is, how does the biosphere affect the climate? So we mentioned that there are certain kinds of organisms, such as bacteria and plants, that take carbon dioxide in and turn it into oxygen. So if carbon dioxide is being removed by photosynthesis, that makes the climate colder. Okay, let's take a break. When we come back, we're going to now apply what we've just learned to geomorphism.